Hello and welcome to this year's Jump into STEM challenge related to equal access to healthy indoor air. My name is Prateek Shrestha. I'm a postdoctoral research associate at the Oak Ridge National Laboratory. To begin with, the indoor air quality in a building, whether it is a house or a commercial building or any type of building with an enclosed environment, depends on air pollutants that are generated either indoors or outdoors. Examples of outdoor air pollution include those generated by power plants and industries, traffic emissions from major highways or roads, and wildfires. And when these outdoor generated air pollutants find their way into a building through either intentional openings like those from the heating, ventilating, and air conditioning system, or unintended minor cracks and openings in a building, those pollutants get transferred into the indoor environment of the building. Similarly, air pollution can also be generated through indoor sources, for example, by cooking activities, combustion equipment and appliances, installed or stored products and materials, the volatile organic compounds off-gassing from furniture, when we use cleaning products to clean the surfaces, and existing building materials like insulation materials, when there is a problem of mold, pests, or if we have pets that shed and give off pet dander into the indoor air, the activities like indoor smoking or naturally occurring radon that seeps into the indoor environment through cracks and openings in the building's floor, or legacy building materials like lead and asbestos that tend to exist in older buildings. And indoor air quality is generally degraded when there is poor ventilation. Most Americans spend 90% or more of their time indoors, where the indoor air pollutants can get concentrated up to 2 to 5 times more than the outdoors. And poor indoor air quality can lead to a number of respiratory and cardiovascular health problems, including respiratory infections, allergies, asthma, COPD, bronchitis, sick building syndrome, and lung cancer. For the short-term or acute exposure to air pollutants, it can cause upper respiratory tract infections and irritation, and respiratory diseases in susceptible individuals. More than 100 people die each year in the United States alone from unintentional exposure to carbon monoxide gas that is generated by the process of combustion and is generally attributed to portable generators and other fuel burning appliances and products. Naturally occurring radon gas is a type of gas that seeps into the building through cracks and openings in the building's floor. It's a soil gas, and radon is associated with lung cancer, and in fact it is the #1 cause of lung cancer in the US among non-smokers. Similarly, secondhand smoke. If there's a smoker in the house, it is the third leading cause of lung cancer, responsible for an estimated 3,000 deaths every year in the US. Poor indoor air quality may also lead to increased school and work absenteeism, loss of work productivity due to reduced cognitive performance, etc. And in extreme cases, poor indoor air quality can even lead to death. There may be several factors contributing to indoor air quality inequity being faced by people. One of the factors is socioeconomic status, which can lead to higher indoor air pollution concentrations, increased infectious disease transmission, injuries, asthma symptoms, lead poisoning, and mental health problems. And there might also be other factors that can lead to indoor air quality inequities such as the age of the occupants, density of housing, home ownership status, race, ethnicity, occupation, and infrastructure development. And the indoor air quality inequity might not just be applicable in the context of residential buildings, but other buildings as well. When we talk about indoor air quality, there is always another topic that comes into the interplay, that is energy efficiency. Recent technological developments in indoor environmental sensing, modeling, and control capabilities can be leveraged to potentially optimize for indoor air quality and energy efficiency in buildings, and also to improve the affordability and access of these solutions to a wider population. Indoor air quality improvement with increased ventilation has also been shown to reduce the risks of COVID-19 transmission in a building, whether it is residential or non-residential building type. Examples of technological solutions of indoor air quality improvement include portable air purifiers, upgrades to the filtration system of heating, ventilating, and air conditioning systems of a building, use of kitchen range hoods that exhaust to outside, heat recovery ventilators, and motion activated mechanical exhaust fans. And the affordability and easy accessibility of these brand new concepts and technologies to a wider population still remains a challenge. What we need is holistic solutions to address the indoor air quality inequity problem, not just technological. Some examples include policies, codes, and standards. For example, the procedures that agencies follow when they work under the U.S. Department of Energy's Weatherization Assistance Program or the U.S. Department of Housing and Urban Development, or HUD in short. There's also a need for collaboration between these already existing programs to co-address the indoor air quality issues in tandem with energy and economic efficiency. And there are some examples listed here that relate to the Weatherization Assistance Program and HUD once again. What we also need is to effectively, economically, and impactfully deliver these great solutions to the end users. So this year's challenge, we are focusing on the holistic solutions that once again include not just technological, but also science, policies, awareness, information technology, economics, codes and standards, etc. behind the inequities in indoor air quality. So what we are expecting the teams to do is the teams have to develop a problem statement to address the indoor air quality inequities for a specific stakeholder group that you identify and present a holistic response to that problem. The few ideas to kickstart your creative thinking are listed here. So some of the ideas may be something like better characterizing indoor air quality to provide better guidance for policy development. For example, if you come up with some novel metrics related to indoor air quality that can show how good or bad the indoor air quality is in a certain type of building, or managing indoor air quality in buildings through targeted sensing and ventilation strategies, or for, let's say, focusing on specific pollutant source, building type, or geographical location. Some other ideas include something like generating or analyzing data through mobile applications, machine learning, databases, etc., for making informed decisions at building or community level. Also, developing innovative financing mechanisms to upgrade existing buildings with improved indoor air quality can be a sort of non-technological solution that you can think of. Another example is identifying new mechanisms of collaboration between already existing programs, but they are not quite functioning well, so you come up with some ideas to make them work better together so that they can co-address the indoor air quality problem in tandem with other issues such as energy efficiency and economic efficiency. So the requirements for this challenge is to first develop a challenge statement and propose a solution related to building or community scale indoor air quality issues. Then describe the scope and context of the problem based on a real building and or stakeholder group. And it has to be in the context of the United States. Then we need you to identify the affected communities, making sure to include socioeconomically vulnerable communities, if any, when compared against a group with higher socioeconomic status. And what we really need you to do is develop a holistic solution, including not just technological, but also policy-related economic, commercialization, or codes and standards, etc., to address the indoor air quality problems at the building or community scale. We need you to discuss the appropriate and expected impacts and benefits of the proposed solution, how it impacts the stakeholders, and this should include cost-benefit analysis of the proposed solution as well as non-economic impacts whenever possible. For example, environmental, noise, security, logistical challenges, health risks, safety hazards, etc. Then we need you to develop a plan that describes how the team envisions bringing this idea from concept to a final implementation, or concept to a market, as they say. In that, we need to develop a detailed plan to convert the idea to, let's say, a commercially viable market-ready product, or a roadmap to integrate the idea into an actual construction or a retrofit project. There are some additional resources. There are more resources in the Jump into STEM website. If you go under the additional resources, and this video is recorded so that you can refer back to it in future if needed. And with that, I would like to thank you. Welcome to the Jump into STEM challenge for this year once again, and good luck for participation in this year's challenge. Thank you.